What if humanity is not the first intelligence to walk this earth? The planet itself is an archive older than memory. Every mountain is a shelf of pages pressed into stone. Every ocean floor is a library of sediment, written and rewritten with the passing of ages. Civilizations, if they have ever risen before, would be like waves on a restless sea. They crest with brilliance, then break and vanish, leaving only a whisper carried forward in the silence of rock and fossil. This is where the Silurian Hypothesis begins. A question that feels almost mythic in scope. Could there have been another technological species on Earth? Long before humanity appeared, a civilization so ancient that its traces have been ground away by plate tectonics, swallowed by oceans or buried beneath layers of deep time. Geologists speak of the Earth as a restless recycler. Crust is destroyed and reborn. Continents drift. Oceans open and close. In such a shifting world, even the monuments of empires vanish. Stone cities become sand. Metal rusts into dust. 1 billion years is enough to erase even the sharpest mark. The hypothesis does not claim certainty. It offers a mirror, one that reflects our own fragility. If we are not the first, what ghosts of intelligence lie beneath our feet? What forgotten echoes are entombed in layers of coal, in the chemistry of ancient sediments, or in isotopes hidden deep within stone? The question lingers, heavy and unsettling. Humanity gazes into the abyss of time and wonders not only who we are, but whether the story of intelligence on Earth has been told before, then lost to silence. Beneath the fragile skin of soil and stone, the Earth is more than a world of rivers and forests. It is an archive, an eternal recorder of all that has unfolded across the ages. Every layer of rock is a page, every fossilized imprint a sentence, every pocket of ice a sealed letter from the past. Geology is the language of this archive. Sedimentary layers capture the slow breath of ancient seas. Lava flows harden into dark chapters of catastrophe. Minerals crystallize into signatures of pressure and heat, preserving not only the violence of tectonic shifts, but the whispers of climate long vanished. The record is imperfect, eroded and rewritten by time, yet fragments remain. To read them is to stand in dialogue with worlds long extinguished. Ice too holds memory. Deep cores drilled from Greenland and Antarctica are translucent scrolls, layer upon layer of snowfall compressed into crystal. Within their depths lie trapped bubbles of ancient atmosphere, records of the air that once filled the lungs of mammoths and giant ground sloths. Each layer tells of volcanic ash that drifted across continents, of carbon fluctuations that shifted the rhythm of ice ages, of the delicate balance between warmth and frost. The fossil record adds its own testimony. A tooth in stone, a leaf pressed into shale, the scattered bones of creatures whose names are only guesses. They remind us that extinction is not a rare punctuation in Earth's story, but the steady heartbeat of its evolution. 99% of all species that have ever lived are gone. They survive now only as echoes, preserved in the rock library beneath our feet. In recent years, scientists have introduced a new chapter in this archive. They call it the Anthropocene. It is the idea that humanity's presence is now inscribed into the very geology of the planet. Our cities, our industries, and our inventions are not just fleeting arrangements of matter. They are leaving behind chemical and physical signals that will endure for millions of years. Plastics, nearly indestructible, drift to the deepest trenches of the oceans. Fragments of them settle into sediments, forming a new layer that will tell future geologists of our presence. Nuclear isotopes, forged in weapons tests of the 20th century, are another indelible mark. Fallout particles, spread across the globe by winds and currents, embed themselves in soil and sediment. Even if humanity were to vanish, these isotopes would linger, detectable for hundreds of millennia, silent markers of an age that once burned with unnatural fire. Industrial pollutants, heavy metals, and altered carbon cycles join the signal, weaving together a complex geological fingerprint that says, humans were here. And yet the paradox deepens. If humanity disappeared tomorrow, how much of this signal would truly endure? The slow churn of plate tectonics would erase continents, swallow oceans, and recycle crust into molten depths. Glaciers would carve new valleys, winds would sand mountains to dust, and seas would bury evidence beneath layers of sediment. 100 million years from now, would our skyscrapers still whisper of our existence, or would they dissolve into the background hum of stone? It is a question that does not end with us. If Earth holds the record of our presence, might it once have held the record of another? Could there have been an earlier civilization, long before the first humans, that left its own signal? Perhaps in isotopes we have yet to recognize. Perhaps in anomalies erased by the restless geology of deep time. The Silurian Hypothesis asks us to imagine this possibility not as fantasy, but as scientific challenge. If another intelligence rose and fell, its echoes may still linger, subtle and hidden within the archive. To search for them is to confront the vastness of geological memory, and to recognize that even the mightiest signals fade against the patience of a planet that thinks in eons. The Earth remembers, but it does not remember everything. Its archive is both vast and fragile, preserving fragments while erasing volumes. And within those absences lies the unsettling possibility that the story of intelligence may not be written here for the first time. In the spring of 2018, a paper appeared in the pages of the International Journal of Astrobiology. Its title was quiet, almost academic. The Silurian Hypothesis. Would it be possible to detect an industrial civilization in the geological record? Yet behind its words lay a question that shook the foundations of how humanity imagines its place in time. The authors were Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and Adam Frank, an astrophysicist from the University of Rochester. These were not fringe thinkers, not seekers of myth, but scientists working at the highest levels of climate and planetary research. And the idea they proposed was as daring as it was unsettling. They asked not whether there had been an ancient civilization before us, but something subtler. If there had been, would we even be able to tell? Would the record of Earth, restless and imperfect, preserve its existence, or would the memory of it vanish into silence? Their work was not meant to prove an ancient Atlantis, nor to claim that hidden empires once flourished beneath vanished skies. Instead, it was a thought experiment, an exploration of what kinds of fingerprints industrial activity leaves upon a planet, and how long those fingerprints can endure. The name they chose, the Silurian Hypothesis, carried its own story. It did not come from the Silurian period of Earth's history, which stretched from 443 to 419 million years ago, when seas swarmed with armored fish and land was only beginning to bloom with plants. Instead, it came from fiction. In the long-running series Doctor Who, the Silurians were imagined as a race of reptilian beings who had built advanced civilizations on Earth before humanity rose, retreating underground when catastrophe struck. By borrowing the name, Schmidt and Frank were signaling something important. This was not a claim of lost reptilian empires, but an intellectual exercise, one meant to test science itself. Their starting point was simple yet profound. Humanity today is leaving behind what scientists call a techno-signature, the geological imprint of industrial civilization. From plastics and synthetic chemicals to altered isotopic ratios, our age is inscribing itself into stone and sediment. In the far future, if another intelligence were to study Earth after humanity's disappearance, what would they see? And by turning the question backward, they asked, if another species once reached such a stage long before us, how would we detect them now? The heart of the hypothesis lies in the geological record. Earth is a restless archivist. It writes with wind, water, and fire. It erases with equal ease. Mountain chains rise and crumble. Oceans spread and close. Entire crusts are swallowed by subduction zones, recycled into the molten mantle. Only fragments survive the churn. Even so, patterns can be read, and signals can endure for millions of years. The scientists focused on several possible markers. One was isotopic. Industrial activity, particularly the burning of fossil fuels, changes the balance of carbon isotopes in the atmosphere. Ancient plants prefer lighter carbon atoms, leaving a subtle bias in the ratios of carbon-12 to carbon-13. When humanity burns those fossil remains, the isotope balance shifts again, detectable in sediments. This Suez effect is already recorded in ice cores and soils today. If an earlier civilization had burned ancient hydrocarbons, their industrial age might have left a similar isotopic anomaly hidden within ancient stone. Another marker was chemical. The industrial age creates substances that nature does not. Plastics, with their long chains of synthetic polymers, are nearly indestructible on human timescales. Fragments of them now rain into the deepest trenches, embedding in sediments that will one day form rock. Synthetic fertilizers alter nitrogen cycles. Industrial metals and persistent organic pollutants spread globally, becoming locked into soils and clays. In principle, these signatures could last for millions of years, strange anomalies in otherwise natural strata. If something like this existed in the deep past, it would be a faint but detectable whisper. Mass extinction events provided another angle. Industrial civilization, as Schmidt and Frank noted, drives climate change. Rapid warming alters oceans, diminishes biodiversity, and disrupts ecosystems on a planetary scale. In the geological record, such events often appear as sudden losses of species and shifts in sediment chemistry. Earth's history contains many such extinctions, some triggered by asteroid impacts, others by volcanic outpourings that flooded continents with basalt and filled skies with carbon dioxide. Yet, could one of these events, seemingly natural, have been partly driven by the hand of an ancient industry? It is a provocative question, not because evidence exists, but because it demands humility. Catastrophes in the past may conceal causes we cannot yet imagine. To ground the idea, Schmidt and Frank emphasized its scientific purpose. It was not to speculate about mythical civilizations, but to refine the search for life, both on Earth and beyond. If Earth itself might have buried the traces of an earlier species, then how much more difficult would it be to detect the traces of civilizations on distant planets? Glimpsed only through faint spectra and atmospheric chemistry? By testing the limits of Earth's memory, they hope to sharpen the tools with which humanity scans the stars. Still, the implications ripple outward. The Silurian Hypothesis is less about proving what was and more about revealing what could have been. It frames humanity not as the inevitable crown of evolution, but as one possible expression of intelligence on a planet that has hosted life for billions of years. If deep time can swallow even the grandeur of continents, why not the achievements of civilizations? It is an unsettling perspective. The ground beneath our feet becomes not merely stone, but a palimpsest, scraped clean and written over countless times. The fossil fuels that drive our modern world are themselves the remnants of ancient life, pressed into black seams of coal and reservoirs of oil. To imagine that others may have once burned them long before humans evolved is to glimpse the vast cycles that bind biology, geology, and intelligence together. The Silurian Hypothesis does not claim answers. It asks a question, and in that question lies its power. What would remain if humanity fell today? What traces would endure in 100 million years? And if those traces would be faint, perhaps barely discernible, then might another have already passed through this stage, leaving only a subtle distortion in the deep archive of Earth? The answer is unknown, perhaps unknowable. Yet the act of asking shifts the ground beneath us. It transforms the human story from singular to conditional. It reminds us that the Earth has carried many chapters, most erased, some barely legible. And in its silence, it forces humanity to consider that intelligence, no matter how advanced, may always be temporary against the vast patience of time. Time on Earth does not move in human scales. It flows like an ocean whose tides are measured not in centuries, but in millions of years. Deep time stretches beyond imagination, a vast continuum in which entire civilizations, entire species, even entire continents rise and vanish without leaving more than a trace. Humanity lives within a flicker of this immense story, yet the planet itself remembers in eons. And in those eons, memory is fragile. Geology shows why. The surface of the Earth is restless. Mountains climb skyward only to be ground into dust by wind and rain. Rivers carve valleys that widen, flood, and collapse. Deserts bury cities, then shift, uncovering them only to erase them again. But these forces of erosion are only the surface of forgetting. Beneath them lies the deeper engine of planetary memory, plate tectonics. The continents drift across the globe, pulled and carried by convecting mantle beneath. Crust is consumed at subduction zones, drawn downward into the heat of the mantle where rock melts, reforms, and one day rises again as volcanic outpourings. Over hundreds of millions of years, this cycle consumes almost all of Earth's original crust. The oldest seafloor on the planet today is just 200 million years old, a brief fragment when compared to the 4.5 billion years of Earth's existence. Oceans, vast as they seem, are temporary basins, their floors continuously destroyed and remade. If an industrial civilization once built upon the coasts of an ancient sea, its foundations would now be ash and magma, erased beyond recovery. Even fossils, the rarest of archives, testify to this impermanence. Life has been abundant for billions of years, yet the fossil record is a fractured story. Most organisms leave nothing behind. Flesh decays, bones crumble, shells dissolve. Only under the rarest of conditions, rapid burial, mineralization, the absence of oxygen, does the echo of a creature survive in stone. 99.9% of all species that have ever lived on Earth are gone, and most without a fossil to mark their existence. The image of prehistory built by paleontology is not a complete mural, but a scattering of brushstrokes. Vast chapters of life are absent, erased by chance and time. This imbalance in preservation extends to artifacts as well. Human structures, remarkable as they seem today, are built upon fragile foundations. Skyscrapers may tower for centuries, but wind, frost, and flood will bring them down. Concrete crumbles under chemistry. Steel rusts into flakes. Glass fractures into grains. Even under the most generous conditions, most artifacts would vanish in less than 10,000 years. Some remnants may endure longer: radioactive isotopes, fragments of plastics, or the bones of our great cities entombed in sediment. But in the span of millions of years, will even these survive? Consider the Great Pyramids of Giza, structures already thousands of years old. Given tens of thousands of years more, shifting sands, earthquakes, and erosion will consume them. Given millions, the ground itself may sink, fracture, or subduct. The message they carry, so deliberate, could vanish as though it never was. Even monuments that seem eternal are fleeting against the scales of deep time. Land, where most civilizations rise, is the most fragile of all archives. Continents themselves fracture, collide, and sink. Their coastlines flood and retreat with shifting climates and rising seas. What remains of an ancient city is more likely to be swept into the ocean than to be preserved in a desert or buried beneath volcanic ash. And the ocean floor, as science shows, is the least permanent place of all, recycled every few hundred million years. In this light, the question becomes haunting. What could survive the constant erasure of a planet that remakes itself endlessly? Philosophy lingers in these geological truths. Human beings think of permanence in terms of stone, steel, and architecture. Yet permanence on human timescales is not permanence on Earth's. The idea that a building may last 1,000 years comforts the imagination. But in 1 million years, or 10 million, the question is no longer what survives. It is whether anything recognizable survives at all. Even nuclear waste, so often imagined as a legacy that will outlast us, decays into invisibility over tens of millennia. Plastics, though persistent, are vulnerable to heat, pressure, and chemical transformation. What seems indestructible to us may be reduced to chemical whispers, indistinguishable from natural deposits, by the patient churn of eons. This fragility is not only a matter of human concern, it lies at the heart of the Silurian Hypothesis. If another civilization had once existed millions of years before humans, what would remain? Perhaps nothing but subtle shifts in isotopic ratios or chemical anomalies in ancient sediments. The cities, the technologies, the cultures, gone. All swept into the silent machinery of the planet. The idea unsettles because it suggests absence does not mean non-existence. Erasure is not proof of emptiness. Deep time erodes not only stone, but certainty. It forces humility, stripping away the comfort of believing that what exists now will be visible forever. For every fossil, every artifact, every monument, there are countless others that disappeared without record. The Earth is not a perfect librarian. It is a restless editor, keeping fragments while discarding volumes. What remains to us is not the full story, but scattered sentences in a book that is always being rewritten. And so humanity stands in the paradox of memory and forgetting. Our artifacts may last for thousands of years, perhaps tens of thousands, yet the churn of Earth's geology moves in millions. What feels eternal may already be fading. What seems indestructible may already be dissolving. Against the backdrop of deep time, permanence becomes illusion, and the question grows sharper. If another intelligence walked this Earth long before us, is it any wonder that we see only silence? The Earth's crust is more than stone. It is a palimpsest, layered with records of fire, flood, and silence. To those who study its depths, it reads like a library where pages are missing, where chapters end abruptly, where sudden shifts in chemistry signal events whose causes remain uncertain. If an ancient industrial civilization ever walked this planet, its memory would not survive in monuments or artifacts. It would survive as whispers in the rocks. And to find them, scientists must search for signals that nature does not easily explain. One such signal lies in isotopes, the subtle fingerprints of chemistry. Carbon itself tells a story. In natural cycles, the ratio of carbon-12 to carbon-13 remains steady, shaped by biology and volcanic exchange. But when fossil fuels are burned, the balance changes. Plants long buried prefer carbon-12, and when their ancient remains are released into the atmosphere, the isotopic ratio shifts in measurable ways. Already, geologists can see this human signature in modern sediments and ice. A future intelligence studying layers of stone millions of years from now would recognize it as a sudden and artificial spike. If an earlier civilization once tapped into similar reserves of buried carbon, its passage might also be marked by an isotopic anomaly. Other isotopes carry their own clues. Plutonium, for instance, is virtually absent in nature, existing only in trace amounts from rare natural fission. Yet in the 20th century, humans forged it in abundance, scattering it into the soil through weapons testing and nuclear industries. Its half-life is long enough that traces will persist for hundreds of thousands of years. To discover plutonium in a layer of rock millions of years old would be a signal of something extraordinary, something artificial. The same is true of plastics, strange polymers with no natural counterpart. Already, fragments of them are drifting into sediments, forming what some researchers call plastiglomerates, hybrid stones of sand, shell, and plastic fused together by heat. In the far future, they may endure as strange fossils, unlike anything Earth produced before. But isotope shifts and chemical anomalies are not the only fingerprints of industry. Civilization reshapes the climate itself. The burning of carbon drives warming, raising global temperatures, acidifying oceans, and altering ecosystems at a pace far faster than natural rhythms. In the geological record, such disturbances appear as sudden carbon spikes, moments when the balance of Earth's systems veered wildly, with consequences that rippled through every layer of life. Some of these events remain mysteries, their causes uncertain, and it is within these mysteries that speculation grows. One of the most striking examples lies in the Paleocene-Eocene thermal maximum, or PETM. 55 million years ago, the planet's temperature surged by 5 to 8 degrees Celsius in less than 200,000 years. Carbon flooded into the atmosphere and oceans in quantities rivaling those of today's industrial emissions. The deep sea grew acidic, many species vanished, and ecosystems reshaped themselves in response to the sudden change. The cause remains debated. Some point to massive volcanic activity, others to the release of methane from frozen hydrates beneath the sea. Yet the precise trigger remains elusive. For Schmidt and Frank, the architects of the Silurian Hypothesis, the PTM represents a case study. If a civilization had once flourished and fallen in that age, its collapse might look remarkably similar to the record we see. A sudden carbon spike, unexplained, buried beneath 55 million years of sediment. Other anomalies echo the same uncertainty. Layers of unusual isotopes appear at different points in Earth's history. Sudden extinctions punctuate the fossil record, some clearly tied to impacts or volcanism, others more ambiguous. Geologists speak of mystery layers, thin but global sheets of chemical change, where something unusual happened that the rocks do not fully explain. Some may be natural, the consequence of Earth's volatile rhythms, but others remain enigmatic, their causes still debated after decades of study. It is within these anomalies that the search for ghost civilizations finds its footing. Not as proof, but as possibility. If natural forces can mimic the signatures of industry, then distinguishing one from the other becomes a test of perception. Could the PTM, for instance, have been entirely natural? Almost certainly. But could the same isotopic pattern in another context hint at something more? The line between natural and artificial blurs when the record is incomplete. To explore these questions is to confront both science and philosophy. The evidence required to prove an ancient civilization is almost impossibly subtle. It would not be found in ruins or artifacts, but in chemistry. Ratios of carbon that suddenly shift. Isotopes that appear where none should. Layers of plastic or synthetic material, fossilized into stone. Yet even these signals may erode, dissolve, or become indistinguishable from natural anomalies. The challenge is not only to look, but to know how to read the silence between the lines. In this light, the search becomes less about finding ghosts in the rock, and more about testing the limits of human science. If Earth itself hides its secrets so well, how much harder will it be to read the history of other worlds? When astronomers scan the atmospheres of exoplanets for chemical signatures of life or technology, they face the same dilemma. Is a spike in methane the breath of biology, or the outgassing of geology? Is a rise in carbon dioxide the mark of industry, or the release of volcanic fury? By asking whether an ancient civilization could hide in Earth's own record, scientists sharpen their tools for seeking intelligence across the stars, and yet the haunting possibility remains. If a ghost civilization once lived and died on Earth, the evidence may already be beneath our feet, written in layers of stone we have not yet studied deeply enough, or written so faintly that we no longer know how to read it. Every unexplained anomaly becomes a question, every missing piece of the record, a silence that may conceal more than chance. In the end, the search for ghost civilizations is less about proving the past and more about reshaping perspective. It reminds us that the absence of evidence is not evidence of absence, that what seems permanent may vanish in the churn of deep time. That civilization, no matter how advanced, may leave behind only a faint signal, indistinguishable from nature itself. The Earth carries many mysteries in its archive. Some are explained, others remain open. In those gaps lies the unsettling possibility that intelligence has already come and gone, leaving behind only the faintest of chemical shadows. The fossil record speaks in fragments, in bones and shells pressed into stone. It tells us of creatures that walked, swam, and soared across eras so distant that even the imagination struggles to hold them. Yet it does not tell us everything. 99.9% of all species have left no fossil behind. Most of life's experiments are gone without record, erased before they could be known. In this silence, speculation grows. If another intelligence rose before humans, what might it have been? The age of the dinosaurs dominates the imagination. For more than 150 million years, reptiles ruled the Earth. Some were massive, lumbering giants. Others were agile, sharp-eyed hunters with brains larger than instinct alone demanded. Among them were the troodontids, small feathered dinosaurs with unusually large brains for their body size, complex eyes, and grasping hands. Paleontologists note that their brain-to-body ratio approached that of modern birds, edging into a range where problem-solving and flexible behavior become possible. If evolution had tilted slightly differently, if the asteroid that struck 66 million years ago had missed its mark, could a lineage of reptilian intelligence have emerged? Perhaps not cities of steel, but communities shaped by scale, feather, and claw. The idea is speculative, yet grounded in evolutionary possibility. Intelligence is not an inevitable outcome, but it is a recurring theme in the story of life. Birds, descended from those same dinosaurs, show remarkable cognitive skills today. Crows bend wires into hooks to reach food. Parrots understand abstract categories. Ravens plan for future events, hiding food to retrieve it later. If such abilities can emerge in modern birds, could they not have developed more fully in another branch of their dinosaurian kin? But reptiles were not the only candidates. During the Mesozoic, mammals lived in the shadows, small and nocturnal, eking out existence beneath the feet of giants. Yet even then, their lineage was experimenting with complexity. By the time dinosaurs fell, mammals were poised to diversify, and intelligence was one of the paths open to them. The great apes, including humans, are only one branch of this story. Could another mammalian experiment have unfolded millions of years earlier? Perhaps not in primates, but in ancestors of elephants, with their profound memory and social bonds. Or in dolphins, whose communication and self-awareness suggest a sophisticated inner life. Intelligence could have flowered in forms we now see only as hints. The ocean holds even deeper mysteries. Beneath its shifting currents, cephalopods, octopuses, squid, and cuttlefish, evolved minds startlingly different from our own. With neurons spread through their arms, they experience the world in ways alien to vertebrate thought. They solve puzzles, escape enclosures, and show evidence of short and long-term memory. Their lifespans are short, their bodies fragile, but their intelligence is undeniable. Imagine, then, an ancient epoch when conditions allowed cephalopods to live longer lives, to pass knowledge from one generation to the next, to weave a culture in the twilight zones of the sea. If such a civilization had risen, it would leave little trace. No stone tools, no cities on land, only faint disturbances in the chemistry of sediments lost to the recycling churn of the ocean floor. Speculation stretches further still. Intelligence does not belong to any one body plan. Evolution experiments endlessly. It could have arisen in forms stranger than imagination allows. In reptilian predators with binocular vision and cunning. In mammalian foragers with dexterous hands. In ocean dwellers with distributed minds. Each possibility carries the same haunting question. If they once looked upward at the stars, what stories did they tell themselves about the lights scattered across the night? It is here that the reflection turns cinematic, for the question is not only scientific but existential. If they existed, their civilizations would have dreamed just as ours does. They may have woven myths about the turning of seasons, about constellations shifting slowly overhead. They may have wondered about their own origins, about death, about meaning. They may have asked questions we still ask, in languages now lost, in voices erased by time. And if they vanished, then so too did their dreams, scattered into the silence of deep time, unrecorded and unrecoverable. Science demands caution. There is no evidence that such civilizations ever existed. Yet the very act of wondering reframes humanity's place in the cosmos. It forces humility. For if intelligence is not unique to humans, if it is instead a potential woven into the fabric of evolution, then our existence is not the culmination of Earth's story, but one chapter in a longer and less certain narrative. This reflection is more than fantasy. It is grounded in the understanding that intelligence evolves where it can. It has appeared independently in corvids, in cetaceans, in cephalopods, in apes. The planet seems to experiment repeatedly with cognition. Most of those experiments lead nowhere. Some end in extinction. But one, our own, has so far endured. If intelligence can arise multiple times in one planet's history, then perhaps Earth's silence is not the silence of absence, but the silence of forgetting. The question grows heavier in its implications. If they existed, who were they? Were they beings of claw and feather, carving meaning into the forests of the Mesozoic? Were they mammals with hands that built tools we will never recover? Were they cephalopods dreaming in the lightless oceans? Or were they something stranger still, a lineage unimagined, lost before the faintest fossil could preserve their passage? The answer is unknowable. Yet the question itself reshapes the horizon. For in asking, humanity learns to see its own fragility reflected in the mirror of time. To imagine what might have been is also to recognize what could yet be lost. Civilizations, no matter their form, rise and vanish. Stars are looked upon, stories are told, dreams are shaped, and then perhaps all of it dissolves into silence. If they existed, their voices are gone. But their possibility lingers, haunting the stones, the oceans, the sky. It is the echo of a question that does not end. If they existed, who were they? And if they did not, then why does the Earth feel vast enough to suggest that they might have? Civilization sees itself as enduring. Towers of glass, highways of steel, archives of data stored in servers that hum with power. These are imagined as monuments of permanence. Yet in the quiet measure of geological time, they are fragile, no more lasting than a ripple on the surface of the sea. To understand the possibility of forgotten civilizations, humanity needs only to look inward, to hold a mirror to its own reflection and ask what its signal would look like if buried in the depths of time. The Anthropocene, the age marked by human activity, is already visible in the record. Plastics, isotopes, concrete, and carbon are not merely products of culture. They are geological signatures layered into sediment and ice. A future geologist, studying the stones of what was once our era, would read these markers as sudden and unnatural. A sharp carbon spike, the fingerprint of fossil fuels released in a geological instant. A scattering of radioactive isotopes forged in nuclear fire and spread across every continent. The strange chemistry of plastics, resistant to decay, settling into strata that nature never designed. This is the signal of humanity's presence. It is powerful, distinct, and undeniable, yet it is also temporary. For permanence is not measured in centuries or millennia, but in millions of years. A city abandoned begins to unravel in days. Within weeks, weeds push through concrete. Within years, roofs collapse and glass fractures. In a century, forests reclaim foundations, rivers redirect, storms dismantle walls. Within 1,000 years, steel rusts to flakes, concrete crumbles into gravel, and monuments lie buried beneath shifting earth. In 10,000 years, little remains recognizable, and in 1,000,000, the crust itself may erase the memory entirely. The fragility of knowledge is even more stark. The vast libraries of human history, books, archives, digital servers, depend on maintenance and preservation. Remove the hand of care, and paper rots, ink fades, and servers lose power, their information lost in a silence that no archaeologist of the future could decode. The internet, vast as it seems, is no more permanent than smoke in the wind. The wisdom of civilizations is fragile compared to the endurance of isotopes, sediment, and stone. What endures is not culture in its richness, but its faintest chemical shadow. Even great monuments, imagined as eternal, reveal their impermanence. The Great Wall of China stretches across deserts and mountains, yet erosion gnaws at its edges. The pyramids of Giza, standing for thousands of years, are already weathered by sand and wind. Given millions of years, they too will vanish, ground to dust, buried beneath seas or fractured by tectonic shifts. What humans see as lasting is only lasting relative to human lives. Against the span of deep time, all monuments are temporary. This truth reshapes perspective. Humanity is not the inevitable end of evolution's story. It is one of many waves. Life rises in complexity. Intelligence flowers. Civilizations build, and then time erases. Another may follow. Perhaps others have already come and gone. To stand in the present is to occupy one crest in an ocean of countless swells, none more permanent than the others. The reflection has been echoed by some of the greatest voices of science. Albert Einstein spoke of the incomprehensibility of a universe that nonetheless seems comprehensible, as though intelligence itself is both fragile and cosmic. Stephen Hawking warned that advanced civilizations may carry the seeds of their own destruction, their survival never guaranteed. Carl Sagan reminded humanity of its smallness, describing Earth as a pale blue dot suspended in the dark, a fragile home where civilizations rise and fall, their traces perhaps indistinguishable in the vastness of time. In this mirror, humility is unavoidable. The story of humanity is not written in permanence, but in impermanence. Its libraries, its cities, its cultures may dissolve. Its signal may reduce to a faint isotopic anomaly, a chemical quirk in the layers of stone. Yet this does not diminish its meaning. Rather, it magnifies it. For to exist at all in the vast silence of the cosmos is rare and perhaps miraculous. The Silurian Hypothesis does not claim that others came before. It asks whether, if they had, we would know. And in answering, humanity must admit that its own presence may one day be as invisible as theirs. The mirror reflects not certainty, but humility. Civilizations are waves. They rise, crest, and fall. Their stories may be forgotten, their dreams dissolved, their monuments erased. What remains is not permanence, but the fleeting brilliance of existence, the light of minds that wondered, that reached for the stars, that told stories against the dark. Humanity's place in deep time may be temporary, but in its impermanence lies the echo of something profound. The recognition that intelligence, fragile though it is part of a larger pattern. A pattern written not in permanence, but in cycles. What if humanity is not the first? The question lingers like an echo, carried across the abyss of time. It hovers in silence, not demanding an answer, but reminding that some mysteries are too vast for certainty. For in the measure of billions of years, a civilization, even one that believes itself immortal, is but a brief spark against an endless dark. The Earth has spun for 4.5 billion years. Oceans have opened and closed. Continents have drifted across the globe, colliding, breaking, sinking into the mantle, and rising again. Entire lineages of life have flourished, then vanished, leaving only fragments in the rock. In such a world, what is the lifespan of civilization? 10,000 years? 50,000? Against deep time, even 100,000 is a breath, a ripple on a tide that has rolled unbroken since the first cell stirred in ancient seas. Civilizations imagine themselves permanent. They build pyramids, carve monuments, write libraries, store knowledge in glowing servers and humming machines. Yet permanence is an illusion. Erosion will wear the monuments down. Stone will fracture. Steel will rust. Knowledge, fragile as light, will vanish when the machines fail. Even isotopes and plastics, the most durable of our signals, will one day be buried, eroded, or recycled into the Earth's restless crust. If another civilization once stood here, their artifacts may have already dissolved into silence. And one day, ours may too. The thought is humbling, almost unbearable. Humanity clings to the belief that it is unique, that intelligence bloomed here for the first and only time. But uniqueness may be an illusion born of forgetfulness. The fossil record preserves less than a sliver of life's story. 99.9% of species vanish without trace. Why not civilizations as well? What if there have been others? Brief waves of intelligence rising and falling, erased by the patient hand of deep time. And what would it mean if proof were found? Would it change destiny? If humanity discovered that another intelligence once rose and fell, would it alter the course of its own story, or would it follow the same path, collapsing into extinction despite the warning etched in stone? Perhaps intelligence itself carries the seeds of its own impermanence. Perhaps civilizations, no matter how advanced, always push against the limits of their world until collapse is inevitable. The question has no answer, only speculation, but it shadows every reflection on the fragility of human progress. Carl Sagan once wrote of the pale blue dot, this tiny world suspended in cosmic night, home to every life, every story, every civilization. To think of it as singular is comforting. To imagine it as one among many waves of forgotten intelligence is less so. Yet in this perspective lies humility. Humanity is not the culmination of evolution's long march, but a brief participant in an ancient pattern. Stephen Hawking warned that advanced civilizations may not endure. Albert Einstein reminded that the universe itself, vast and incomprehensible, may erase every trace of thought it ever inspired. And so the question returns, unresolved. Would finding others in Earth's past grant meaning or strip it away? Would it inspire caution or deepen despair? Would it change the way humanity looks to the stars? Or would it only remind us of our fragility, our impermanence? Perhaps the truth will never be known. Perhaps the silence of the Earth is not proof of absence, but proof of forgetting. The rocks remember in fragments. The oceans erase. The mantle recycles. The archive of Earth is vast, but it is not eternal. In its absences, there may be ghosts of stories untold. The cinematic close is not revelation, but reflection. Civilizations rise, they fall. They leave signals faint and fleeting. Then they vanish, carried away by the great tide of time. Humanity may be no different. One wave among many, destined to rise, crest, and fade into the silence. Perhaps the Earth has forgotten others before. Perhaps it will forget us too. Yet in this forgetting lies the deeper mystery, that life itself, fragile and fleeting, continues to rise, fall, and rise again, a tide older than memory. A rhythm written not in permanence, but in renewal. And so the question remains, lingering like a shadow at the edge of thought. What if we are not the first?